Okay, so let's look at the skills on chapter 1. So the very first skill that we see is place value to the billions place. Now, obviously, you all, some of these skills are very simple. They should be very simple for you right now. So we're going to move kind of fast through this and not do every single skill. But what it means, place value to the billions place, simply means that if the test gives you a problem like 436,387, and they underline that digit, your job is to be able to tell what place that digit is sitting. So here's our example problem. The answer that we would be searching for would be the name of the place of that 3 and where it's sitting. Not its value, just the name of the place. So who can tell me, this is a whole number, there are no decimals. So Emily, what place is that 3 sitting in? What? That's the 10,000s place. Very good. Okay. The 10,000s place. Now, Emily, if it asked for the value, what would be the value of that 3's digit? If it's in the 10,000s place, if you have 3 10,000s, how much do you have? If the 3 is in the 10,000s place, it has a value. What's it worth? 36? Henry, what's its value? 30,000. If I have 3 10,000s and I put all those together, its value would be 30,000. So there might be a question on the test that asks you to maybe name the place that the digit is sitting or name its value. Are y'all comfortable with that skill?
Yes.
Yes. All right, let's move on to what the next skill would be. So the next skill is powers of 10 using exponents, okay? Now, this might be something that some of you are going to remember once I kind of show you, but currently right now you're like, I don't know that I really remember that. So what would an example of this look like? So let's look at an example like, let's say it was 10 to the 4th power. And you have to tell me what that's equal to.
Oh.
So if you have a 10, that's your base. Your base is 10. 4 is your exponent. Remember, don't make that giant mistake that fifth graders want to make where you multiply the base times the exponent. You don't do that. This will not equal 40, will it? No. What will this equal? Brayden?
10,000.
This will equal 10,000. You drop your 1 and your exponent tells you how many zeros you need in your answer, which is 4. So your answer to that one should be 10,000. You all should be writing this in your notebook with me. Don't just stare at me while I'm doing all of this. I'm doing this for your benefit, okay? Now, what if they give you, though, one where it doesn't necessarily just have the 10 by itself, but it has a number, okay? So here's another example for this. So maybe it's something like 48 times 10 to the 2nd power. What would that equal to? Remember, if on the other one we just dropped the 1, then on this one, let's multiply the numbers that aren't zeros first. So James.
So you, first of all, 10 to the 2nd power, which would be 100, then you times 48 times 100.
Which is?
4.
That's a lot harder how you just did it. If I were you, I would just multiply the numbers that aren't zero first. 48 times 1 is? 48. And then the exponent tells me to add how many zeros?
2.
So your answer is 4,800. That's a lot easier. Okay? You all good with that skill?
Yes.
Okay. Third skill in chapter 1 was the property rules, the addition and subtraction property rules. I really can't give you an example for these. These you just have to memorize. There are small things in math that you do have to memorize. And these properties are things you got to memorize. So am I gonna do an example problem for those? No. You're gonna have to go into your notebook, go back to where you took notes in chapter 1 on what is the commutative property, what is the associative property, what is the identity property. And you've got to refresh your memory on that. Okay? Don't do it now. Do it this evening. I'm not giving you additional homework tonight. So tonight, your homework is going to be to practice for this on IXL or review your notes. All right? But let's move on to then the 4th bullet point, which is adding and subtracting whole numbers. So obviously, that shouldn't sound super scary, okay? But what would it look like? So the 3rd example in this spot would be something like 4,863 plus 247. That looks really easy right now. You're like, all we have to do is add numbers. But for some of you, you will goof up on this. Because you will think it's so easy, you will make a brain burp addition mistake. You will accidentally add wrong. It happens all the time. So the first thing you would do on this problem is you have to rewrite it so that you can line things up. And I've learned this year with this class, not really this class, but with 5th grade, that a lot of times you guys copy things wrong. When you have to take a problem from your computer screen or from your test paper and recopy it onto a piece of paper, sometimes you all copy the wrong problem. If you copy the wrong problem on your math test and you add the digits wrong together, is the computer going to give you a chance to retry? No. So you've got to be careful that on these easy problems like this, you don't go so fast that you make one of those silly mistakes. Okay, so when you add this stuff together, you should end up with 5,110. You guys get that one?
Yeah.
All right, so that's chapter 1. At the start of the school year, that's where we spent a lot of time. That was chapter 1, okay? All right, let's move on to chapter 2. Okay? So, chapter 2. What was chapter 2 about? Well, chapter 2 was all about place value with decimals. So this is when we moved into decimal land and we started learning about things in decimal land. So the very first bullet point says that you need to know what place value with decimals all the way to like the thousandths place looks like. Okay, so let's try some examples here. So your first example might be a problem like something 873.562. And let's say the 6 is underlined. So for this particular problem, you have to determine what's the name of the place that 6 is sitting. So a minute ago in chapter 1, we did it with whole numbers, and Emily told us. But in this example, now we're in decimal land. So Max, what would be the name of the place that 6 is sitting?
Hundreds.
It's in the hundredths. I can't spell. That's totally wrong. My brain is lost. I think I spelled it right. I don't know. The hundredths place. Now, if we get its value, what would its value be?
600.
How do I write 600ths? Remember, in chapter 1, we had to show what 10,000s, like what 3 10,000s looks like as a number. So what would 600ths look like as a number, Max?
Decimal 06.
Yes, it would look like decimal 06. The 6 has to be in the hundredth spot, so I have to fill in that 0 in front of it. Now, some of you might have been wanting to show what it looked like as a fraction. Did any of you do that? You did it? Okay. If you were trying to show what it looked like as a fraction, what would 6/100 look like, Brady, as a fraction? 6/100. Okay. Remember when we did that?
Yeah.
Okay. That's bullet point number 1. All right. Next skill. Decimals in expanded form. So, what does this look like in expanded form? All right. Some of you were like, oh yeah, I remember how to do this. Okay. So, example number 2. Let me give you a number. Let's go with 62.37. And you have to write that in expanded form. So that means you have to give the value of every single digit, and you're going to add the values together. Okay? So James, you want to do this for me?
Yeah.
All right, so what would this look like in expanded form?
60
Yeah,
plus 2
yeah,
plus 3. No, plus 0.3
ooh, good, plus 0.3, plus
plus 0.07.
0.07. Nice work, James.
I have the wrong number.
Huh?
I have the wrong number.
The same thing.
Wait,
Yes.
Would 60 plus 2 plus 3 over 10 plus 7 over 100?
Good question. So he wants to know if 60 plus 2 plus 3 over 10 plus 3 over, oops,
No,
not
7.
3, 7, my bad, going too fast, plus 7 over 100 would be correct. Yeah. But let me tell you, I don't know if the people who make this test will put it like that. They will probably put it as decimals. So you've got to pretty much know both ways. Both ways are right, but I don't think they're going to put it in the answer as fractions. They're going to put it as decimals. Great question though. Okay, yes, we okay on that part? Okay, next bullet point. This is called a crash course, people. We are crashing our brain with information. All right, next one is comparing and ordering decimals. All right, so what does that look like? All right, so when you compare and order decimals, this is example number 3. What that looks like. Let's say that I give you 3 decimals, okay? So here's your decimals. 4.2, that's your first one. 4.02, that's your next one. 4.24, that's your last one. Now, there's 3 decimals. You have to compare them and order them. Comparing means being able to say which one is bigger than the other one. And then ordering them, putting them in order from like the greatest to the least, the least to the greatest. So there will be directions. Please don't read the directions wrong. If they want you to put them in order from the smallest to the biggest, then that's what you have to do. Don't do it the other way around, okay? So who wants to do this one for me? I got to put this in order from the smallest to the biggest. Connor G. Smallest number here is which number?
4.02.
Thank you. 4.02. There might be people in the audience who thought 4.2 was the smallest because it didn't have as many digits. That's not how we order decimals. You got to look at each place's value. They each have a 4. So obviously that didn't give us any help. So then I had to move to the next largest place, which was this place. This one has a 2. This one has a 0. This one has a 2. So obviously the one with the 0 is going to be smaller than the ones that have 2s. So that's why 4.02 was absolutely the smallest. All right, Connor G, what's going to be the next smallest?
4.2.
4.2. Okay, I like it. 4.2 is the next smallest. How did we know this? Well, because now I have to go to the next place because they both have 2s. This one has a 4. This one has nothing. But Connor, what's the same as nothing?
0.
0. So I could pretend like there was a 0 there. What's bigger, 0 or 4? 4. So obviously the next smallest one is 4.2, and Connor, the largest one is
4.24.
4.24. So that, you guys, is the order that you should place these things in, okay? How many of you got that one? Good work, okay. All right, let's look at the next skill. That's how you would compare and order decimals. If you ever have questions, like say, Miss Moan, hold up, I got a question. Okay, anybody got questions yet? Are we good? All right, sweet. Last little bullet point in chapter 2 is rounding decimals. So this sounds like an easy skill, but sadly, I have a lot of people not know how to round. I don't know why that happens. I don't know why we got to be fifth graders and we don't know how to round. That's scary. Rounding is something that was taught much earlier in your math life. Okay, so let's look at a number like, I don't know, let's just look at a number. Let's look at a whole number. Okay, let's say it's like 7, 8, 9, 6. Okay, and the 8 is what's underlined. What do the rules of rounding tell me, Addison?
If it's 5 or higher, you go up to make the number bigger.
If what's 5 or higher, what do I have to look?
You have to look at the numbers to the right.
Yes, I gotta look at the number to the right. So if 8 is my underlined digit, the number to the right is a 9. Remember our little rhyme? It says if the number to the right is 5 or more, go up a floor. So what will 8 turn into, Addison?
It will turn into 9.
It will turn into a 9. The stuff in front, Addison,
They'll stay the same.
stays the same, and the stuff after
Turns into 0.
turns to zeros. If we're looking at a whole number, do the zeros have to stay?
Yes.
Yes. That number right now is 7,900. If I took the zeros off, it would be 79.
Yes.
That's a whole different number, right? We gotta keep the 0. But what if the number was a decimal number, okay? Like 3.295. And, hold on. Actually, 29. Yeah, let's do that one. Now my 9 is underlined. The rounding rules don't change. I still look at the number to the right. The number to the right is 5 or more. So Brody, what's gonna happen? 9's gonna go up a floor, but remember, I can't just turn 9 into a 10. What do I have to do? Turns into a 0, and where does the 1 go? Travels over to the 2. 2 then becomes a 3. Stuff in front stays the same. So my decimal's gonna stay, my 3's gonna stay. The stuff after turns to zeros. In this example, do I need my zeros? No. Will they want you to keep your zeros? No. So if this is the type of question they give you on the test, they're not going to have 3.300 as an answer. They want you to realize that 3.300 should have the zeros taken away, and the answer should just be 3.3. Okay? That's chapter 2. We've just busted through 2 chapters. Pretty good? Okay, let's move on to chapter 3. 5F got through 4 chapters, friends. So we should be able to get through 4 then if they got through 4, right? Okay. Chapter 3, that's what's next on our stuff. And it'd be even better if we got through more than 4. So, chapter 3. This was on multiplication. So we got into chapter 3 and we started learning how to do multiplication. Okay, so gotta add another page. We're into chapter 3 and we're going to learn to multiply. Okay, let's make this page blue. So example number 1 in the multiplication chapter says the first thing that we have to know how to do is we got to know those properties. Again, that's memorizing. So you're going to have to go through your stuff at home. You got to know the commutative, associate, the identity, the zero, and the distributive. So refresh your memory on those at home. Okay. The second bullet point, though, is estimating products with rounding. Okay, what does this mean? So what it means is they're going to give you 2 numbers. Okay, let's say they give you a number like 259 times 134. So if the question says to estimate the product, well, first off, what is product, Xander? What's product?
Is the answer
Answer to a multiplication product. So I'm not gonna waste my time, because remember y'all, this is a time test. I'm not gonna waste my time working out that entire problem and then rounding my answer. That would not be very wise to do. You're gonna take up way too much time doing it that way. So what should you do first, Olivia?
you should round off the numbers and then
Round both numbers first. And I'm gonna round to the highest place. If it doesn't give me a place to round to, like if it doesn't have a number underlined, I'm just gonna round to the highest digit. So in 259, what digit is in the highest place? The hundreds. So what would 259 round to become? 300, yeah. This would round to become this. What would 134, Olivia, round to be? 100. And now I can just multiply those. And that I can multiply really simple. Multiply the numbers that aren't zeros first. So 3 times 1 is 3. And add all those zeros. How many of them are there? Add them all into your answer. 1, 2, 3, 4. 30,000. See how fast I did that? When it's a time test, you gotta do things the fast way so you don't take up too much time trying to do it the long way, okay? But that's estimating products. Any questions on that? Okay, next skill that you see is, oh, sorry, that was estimating product with rounding. We're at the third bullet point already. Multiplying by 2 and 3 digit numbers, okay? So this would be something like 395 times 27. This is a multiplication problem. It's not asking you to round, it's asking you to multiply. So problems like this are going to take you some time. Go ahead and work it out. Now remember, to work this out, you've got to rewrite the problem and you've got to stack numbers on top of each other in the right places. So that's why I say, the ones that are easy and you can estimate, do those fast. The ones that are a little longer and take more time, like this one, make sure you don't copy the problem wrong. That'll be an issue. Hang on. The only time people sometimes have issues with problems like these is multiplication facts. Gotta know your multiplication facts. But I will tell you, you guys get a little bit of an advantage that the other classes don't get, because right there on the wall is a multiplication table. Are the digits really small?
Yeah.
Can I make them big? No. Do I have to cover it up? No. Because the rule says if it's been there all year, it can stay, even on a test day. Okay? You don't understand how to read those kind of charts? So, real quickly, it basically says if you're looking at a number like 6 times 7, you go across the top in blue, find 6, you go down the side, find 7, and then where they connect and cross, that's the answer to 6 times 7. Okay? Okay. So let's walk through this answer real quick. You guys shout this stuff out with me. So the first thing I'm going to do is multiply 5 times 7, which is, everybody?
35.
Oopsies. Drop my 5, carry my 3. 7 times 9 is?
63.
Plus 3 more?
66.
Huh?
66.
66. 7 times 3 is?
21.
Plus 6? 27. Good. Now I'm ready to move on to my next digit. I have to now multiply that 2 by everything at the top. But before I do that, I better remember to put my 0 placeholder If not, I'm gonna end up with the wrong stuff being multiplied or added together, okay? 2 times 5, everybody is? 9 times 2 plus 1 is? 19. 3 times 2 plus 1 is?
7.
And the final step is add it all together. So this is where I told you, I suggested that maybe if you have difficulty keeping things like neat and in order, you could flip your notebook sideways just so that you have the columns. You could use graph paper. I have graph paper back there on the wall if you need it, okay? When you add this stuff up though, you end up with 10,665.
Let's go. Let's go.
So if you made a mistake, look and see my work and see if you can figure out what you did wrong, okay? But that's multiplying 2 and 3 digit numbers. So, all right. There will maybe be 1 or 2 of these on your test. There won't be a ton of them, okay? But you gotta make sure, it'd be like me giving you a test and there only being 1 of these problems on it. If you get the 1 problem right, you're gonna ace that problem. If you get it wrong, you're gonna fail it. So on days of math test, if they only give you 1 of these and you don't get it right, you failed that section. It's gonna look like you don't know how to multiply 2 and 3 digit numbers. So take your time, okay? All right, the last little bullet point in chapter 3 is multiplying with zeros in the multiplier. We're not even gonna practice one of those, but it just means that instead of these being all numbers, one of these would have a 0 inside of it. Okay. That's all it means. So it'd be like 305 times 27. Okay, that's chapter 3. Any questions on chapter 3?
No.
Okay, let's move on to chapter 4. So in chapter 4, we are now into division. Okay, so division is when we learned how to divide not decimals but whole numbers. Okay? All right, so this, let me get my page ready. Chapter 4. And let's go purple this time. So example number 1. So it says compatible numbers. Remember, compatible is a word that means numbers that go together. Okay, so an example of compatible numbers would be like, what do you think? 2,530 divided by 5. Okay. So you're going to use compatible numbers to solve, which means you're not getting an exact answer. Compatible numbers is a type of estimating. So we're going to estimate here. So we're going to look to see, at the beginning of this problem, do you see anything in 2,530 that is compatible with 5? What do you see, Brody?
25.
He sees 25. He noticed that 25 and 5 are compatible numbers. So Brody, about how many 5s would go into 25? 5. What would the rest of the numbers turn into? They would turn into 0. So your answer would be about 500. You kind of remember that?
Yeah, I did it.
Okay.
I was just gonna say, what if you noticed the 30 first before you
You wouldn't do that, because just like if you set this up as a division problem, bud, like if you had 2,530 divided by 5, you wouldn't say 5 goes into 30 first. So, yes, but that's a great question though, okay? Now, what about, so let's look at another example. Let's say that it was 2,530 divided by 50. So we're still just going to look at the 5 first, okay? And we see that 5 is compatible with 25. So again, how many 5s will go into 25? 5. But now we have an issue, because now we have a 5 on the outside, and that 5 is going to eliminate a 0 in our answer, right? So this 5 on the outside eliminates this 5 this 0 on the inside. So how many zeros are really gonna go in our answer? Just one.
What's this lesson?
This is the chapter 4, estimating with division. Do you guys kind of remember that?
Yeah.
So here's what I would suggest if I'm starting to get into something. Some of you, like when we work through some of these, like you're so with it, you get it. But then some of them, like that one, I noticed your facial expressions change. You kind of like, oh, I don't remember that. So what I suggest that you do is maybe put a star by that one. So if you don't really remember exactly how to estimate with division, then that needs to be where you spend time in IXL. Don't spend time in IXL adding whole numbers if you know how to do it. Anything that we do that is a difficult skill for you or something you don't remember, add a little star by it to remind you to practice that one. Okay? All right, let's try to get through chapter 4. We only have like 2 skills left in chapter 4. Division with 1 and 2 digit numbers as well as division with zeros. So that's kind of all the same thing. So what do I mean with it's just basically knowing how to, okay. It's just basically knowing how to do division, okay? So let's just say they give you any problem. It's kind of like the multiplication, but it would be like 948 divided by 22. So that you have to actually solve. You got to figure out the answer, okay? So that means you got to remember that the first number listed goes in the box, right? And the second number's on the outside. I gave you those little tips of does McDonald's serve burgers daily? The steps that you go through to make sure that you don't make a division error, okay? Addison, what?
I have a question. So if like they don't do a division problem and it has a remainder, do they want you to put the remainder as like a fraction or?
Yes, so, yeah. Now, there's a chance they might want you to put it as a decimal, and we haven't gotten to that yet. But, hopefully tomorrow, when we start going through some of this information tomorrow that you haven't seen, I'll kind of give a quick example of that, and that's why you can put in there. But you may have to kind of like practice some of that on your own, okay? All right, so let's set this up. 948 divided by 22, okay? So 22 will go into 94 about how many times? Who wants to take a guess? Somebody says 3? No more than 3? Okay, so let's just make sure if I tried to do 4, that would do 88. That's enough. Yeah, so I would say 4 is going to get me closer. So 4 goes on the roof directly above the last digit I used. I bring down my 88. It's time to subtract. I don't want to make any subtraction errors. 14 minus 8 is 6. 8 minus 8 is nothing. I'm not going to put my 0 there, but you can if you want. Then I have to bring down, oopsies, my next digit, which is an 8. So now I have to start all over. 22 goes into 68 about how many times? 3. 3 times 22 is?
66.
When you subtract, you're left with 2. So this was Addison's question. Will the people that make this test want you to say that the answer is 43, remainder 2? No, that's for sure. Will they want you to know that the answer is 43 and 2 over 22? Well, technically, they won't have that as an option either. Why?
You gotta simplify.
Yes, you got to simplify. 2 over 22 is not in simplest form. So what's 2 over 22 turn into?
1 over 11.
1 over 11. So will they have 43 and 1/11 as an answer? Very possible, yes. But Addison wanted to know, will they expect us to put it as a decimal?
Yeah, 43.
And I don't want you to think that you can just put 0.2. That's not how it works. So I would think that this is how they would expect your answer to be, 43 and 1/11. Okay, I don't see the test. I don't get to see the test, so I can't tell you exactly. But that's what I would say they would expect, because that's what 5th graders are expected to know how to do. They're not expected to know how to convert a fraction to a decimal. So That's what I would say. What?
How would you go about it?
Well, you would then have to take that fraction and you would have to then divide it. And so, that is when we learn how to divide decimals, and we haven't learned to do that yet. Okay? So, all right. That is pretty much chapter 4, honestly, I think. The only other, no, we got a couple other things. The divisibility rules, again, you gotta memorize those. What time am I with y'all? I'm done. All right, so we're gonna take a stop here. So look, here's the plan. You don't have any homework tonight. But what do I expect you to do? So I'm not even, stop talking for a second. I'm not expecting you to do any workbook homework, but I am expecting you to do IXL practice over this stuff. Okay? So make sure that you spend some time tonight, since I'm not giving you something extra, working on the IXL. Okay? All right.
Do you understand